Okay, here we go. Let's talk about the different things for mineral resources. This is section 1, chapter 7. Your objectives for today are going to be explain what ores are and how they form, identify 4 uses of mineral resources, summarize 2 ways humans obtain mineral resources. Okay, so it should be a pretty short chapter. Mineral resources can either be metals such as gold, silver, aluminum, or non-metals such as sulfur and quartz, just as sulfur in matches, quartz is in watches, various things. Notice the different symbols up there. Gold is U, silver is AG, aluminum is AL, etc. Metals can be identified by their shiny surfaces. They're good conductors of heat and electricity, and they tend to bend, or we can hammer them into sheets. That's called malleability. Both those, all 3 of those factors really help us determine what a metal actually is. Most nonmetals have a dull surface and they don't conduct heat or electricity very well at all. Ores. A natural material whose concentration of economically valuable minerals is high enough for the material to be mined profitably. What that means is that this is something, a substance we can sell that's going to make us enough money that it doesn't cost us more to mine it out of the ground. So if we're going to mine aluminum, it's going to cost us $10,000 a day to get a $5,000 profit, then it's not going to be worth it. So you want a high concentration where there's lots of it there. Gold, silver, copper are all native elements that can exist in Earth's crust as nuggets of pure metal. So you've heard of gold nuggets, you've heard of copper and silver, same way. Most other minerals are compounds, 2 or more elements. Any of the minerals we look at are usually compounds. Very common, or very uncommon to find the solids like gold and silver. Some ores, like chromium, nickel, they're much more dense and they sink to the bottom, so they're formed from when the magma cools. As minerals sink, layers of these minerals accumulate at the bottom of the magma chamber, form ore deposits, so you'll get layer after layer of these dense heavy metals, and they'll drop to the bottom. So when we mine in igneous rock areas that have these big pools where we can look for those. There are some, you'll get a lode. Remember the term lode because that's like mother lode. Remember when the people talk about mining for gold, they'll talk about the mother lode. Oh, we hit the mother lode. That's what they're talking about. A lode is a mineral deposits within a rock formation. Heat and chemicals, and they get a chemical reaction with the hot fluids. The fluids a lot of times are boiled away, but it changes the composition of the surrounding rock around it. So the rock around it becomes something different. Remember, we bake and heat that rock. It's a metamorphic rock. Copper, zinc formed by contact metamorphosis. You can also have hydrothermal solutions. That's when you get the cracks in the rock and the liquid's forced through and it's super hot and it changes things around there as it goes through. When they dissolve, hydrothermal solution, new minerals will come out of that solution and they'll fill up those little veins, so you'll get a crack and that water will flow through it. Then when that water actually precipitates, evaporates out, you'll get these minerals left behind and they'll fill in that crack and you'll get a vein in the rock that's a different color. That's one of these minerals we've been talking about. Sometimes we get ore from moving water. Placer deposits are usually at the bottom of a moving water river, and there's a hole in the bottom, and that hole, as the water flows over it, the dense heavy metals and dense heavy materials will sink to the bottom of those holes and fill up those holes. So you get that mechanical action, that movement of water. Fragments of gold, aluminum are released as the rock breaks down by weathering, and to carry those fragments till the current becomes too weak, it drops them into those holes and they fill up. Great place to look when you're mining for those certain elements we're talking about. Sometimes we find minerals that are pretty, for lack of better terminology. You get jewelry. Some of you have a birthstone, a diamond. When you want to, girls, when you got to get married, you want an engagement ring, a diamond ring. Guys, you have to buy one. And same way as they're cut, they're polished, they're really pretty. So we sell them as jewelry. There's also other valuable resources: gold, platinum, silver. And obviously, why they're expensive because they're rare. And some non-minerals have that same non-metallic minerals display extraordinary brilliance and color especially when they're cut for jewelry. Again, going back to diamonds, zirconia, and all those. Calcium, gypsum are used in building materials. Gypsum is what drywall is made of. During mineral exploration, people search for mineral deposits by studying local geography. So they'll look at how geology, excuse me. They'll look at how things are put together and how the earth formed there. And these teams will test rock samples, test all kinds of different things, and then they'll go through and look for various various things in the soil that help to point to the fact that there's obviously something profitable here. Sometimes airplanes can see that from above. They'll see patterns in the rock, magnetism, radioactivity, certain colors stand out. Alright, we're going to talk about different mining now. Subsurface mining is a mining when you see the miners with the hats on and the lights on, and they're down with the pickaxes and they're digging. And okay, we really don't do it that way anymore, but it's under the ground and subsurface. Surface mining means they scrape the top off and strip away all the overlaying rock, and then they pull up the minerals. Surface mining is much more damaging to the environment. Both are damaging, but surface mining is much more damaging. If you look at the picture in the book, with the big circles, those circles are roads, and we're talking about machinery. Mind me in class, and I'll show you some pictures of the machinery we're talking about. But the machinery they use is massive. And then same thing with placer mines. We find those spots in the river, and we send in big scoops down there to scoop up those placer deposits and get the minerals we want out of there. And there are undersea mining. Down in the ocean floor, there's probably millions of dollars worth of deposits that are down there. But it's dangerous and very difficult to mine, so they don't get mined very often. Okay, here's a placer deposit formation. I'm going to move the camera just a touch. Okay, placer deposit formation, you get that moving water and those holes are filled up when the water slows down and drops that stuff off. Same with formation of ores with contact metamorphism. You can see that where the magma comes in and heats up and changes the rocks around it from the hydrothermal action of the water heating up. And both those pictures are in your book, by the way. Okay, take your time, do the reading check. Explain the relationship between carrying capacity and the amount of matter and energy in an ecosystem. That's from last chapter. Pause your video and do it. Here's your answer. The amount of matter and energy in an ecosystem can supply a population of a given size. The maximum it can carry, that is the carrying capacity. And remember, anytime you can pause these to write these down, because I'm going to keep going. If you need longer to write that down, then pause it. Alright, let's compare metals and nonmetals to metalloids. Alright, metals. When you point at them, okay, why is nothing working? I guess I won't do that. Again, maybe we'll do this in class. This should work because it's not. I'm sorry. I will try them in class, see why it's not working.